Good morning. I welcome you all again to this LMS videos lecture series, and this is the eighth session. In this eighth session of aldehydes and ketones, we'll be discussing about reduction of aldehydes and ketones. So, to recollect what we discussed in the last class or last session, so we discussed about condensation process of aldehydes and ketones with ammonia and its different derivatives and the mechanism process. So last class alli hege aldehydes athwa ketones ammonia matte ammonia derivatives jothe react agutte and what are the different products obtained and what is the reaction mechanism ಅನ್ನೋದನ್ನ ನೋಡಿದ್ವಿ. ಫಾರ್ ಎಕ್ಸಾಂಪಲ್ ಹೇಗೆ ಆಲ್ಡಿಹೈಡ್ಸ್ ಅಥವಾ ಕೀಟೋನ್ಸ್ ಅಮೋನಿಯಾ ಜೊತೆ ರಿಯಾಕ್ಟ್ ಆದರೆ ಅಥವಾ ಪ್ರೈಮರಿ ಅಮೈನ್ಸ್ ಜೊತೆ ರಿಯಾಕ್ಟ್ ಆದಾಗ ಇಮೈನ್ಸ್ ಬರುತ್ತೆ. ಸೊ ಹೌ aldehydes and ketones react with hydroxylamine to give oximes, how aldehydes and ketones react with hydrazine to give hydrazones, and we saw aldehydes and ketones reacting with semicarbazide to give semicarbazone. This is what we discussed in the previous class. So coming to this session, as I said earlier, so in this class we will be discussing about reduction of aldehydes and ketones. So aldehydes and ketones undergo several reduction reactions. So reduction ಅಂದರೆ ಏನು ನಮಗೆಲ್ರಿಗೂ ಗೊತ್ತಿದೆ. Reduction is nothing but addition of hydrogen or removal of oxygen, whereas oxidation is nothing but addition of oxygen or removal of hydrogen. So this aldehydes and ketones also undergo reduction reaction. So they can be reduced to alcohols by using reducing agents such as lithium aluminum hydride and sodium borohydride. So aldehydes ಮತ್ತು ಕೀಟೋನ್ಸ್ನ ಆಲ್ಕೋಹಾಲ್ಸ್ ಆಗಿ ರೆಡ್ಯೂಸ್ ಮಾಡ್ಬೋದು. ಯಾವಾಗ ನಾವು ಲಿಥಿಯಂ ಅಲ್ಯೂಮಿನಿಯಂ ಹೈಡ್ರೇಟ್ ಮತ್ತು ಸೋಡಿಯಂ ಬೋರೋಹೈಡ್ರೇಟ್ನ ರೆಡ್ಯೂಸಿಂಗ್ ಏಜೆಂಟ್ ಆಗಿ ಯೂಸ್ ಮಾಡಿಕೊಂಡು ರೆಡ್ಯೂಸ್ ಮಾಡಿದಾಗ we can reduce aldehydes and ketones into alcohols. ಸೊ ಅದೇ ರೀತಿಯಾಗಿ aldehydes and ketonesನ ಹೈಡ್ರೋಕಾರ್ಬನ್ಸ್ ಆಗಿ ರೆಡ್ಯೂಸ್ ಮಾಡ್ಬೋದು ಬೈ ಎಂಪ್ಲಾಯಿಂಗ್ ಕ್ಲೆಮೆನ್ಸನ್ ರಿಡಕ್ಷನ್ ಆ್ಯಂಡ್ ವುಲ್ಫ್-ಕಿಶ್ನರ್ ರಿಡಕ್ಷನ್. ಸೊ ಈ ಕ್ಲೆಮೆನ್ಸನ್ ರಿಡಕ್ಷನ್ ಮತ್ತು ವುಲ್ಫ್-ಕಿಶ್ನರ್ ರಿಡಕ್ಷನ್ reaction ಮತ್ತು ಮೆಕ್ಯಾನಿಸಮ್ನ we will be seeing in this session, and at last we will see what is managed reaction. So Clemmensen reduction. So this Clemmensen reduction is the classical method for the reduction of aldehydes and ketones to hydrocarbons using zinc amalgam and concentrated hydrochloric acid. ಸೊ ಇಲ್ಲಿ ಈ ಕ್ಲೆಮೆನ್ಸನ್ ರಿಡಕ್ಷನಲ್ಲಿ ನಾವೇನು ಮಾಡ್ತೀವಿ ಅಂದರೆ ಆಲ್ಡಿಹೈಡ್ಸ್ ಅಥವಾ ಕೀಟೋನ್ಸ್ನ ಹೈಡ್ರೋಕಾರ್ಬನ್ಸ್ ಆಗಿ ರೆಡ್ಯೂಸ್ ಮಾಡ್ತೀವಿ. ಇಲ್ಲಿರ್ತಕ್ಕಂಥ ಕಾರ್ಬೋನಲ್ ಗ್ರೂಪ್ ಇಸ್ ರೆಡ್ಯೂಸ್ಡ್ ಟು ದ ಮೆಥಿಲಿನ್ ಗ್ರೂಪ್. ದ CO group is reduced to the CH2 group. So since there is deoxygenation or removal of oxygen, the carbonyl oxygen and addition of 2 hydrogen atoms, we call this reaction as a reduction reaction. So Clemmensen reduction uses an acidic solution of zinc metal dissolved in mercury. ಸೊ ಕ್ಲೆಮೆನ್ಸನ್ ರಿಡಕ್ಷನಲ್ಲಿ ನಾವೇನು ಮಾಡ್ತಾ ಇದ್ದೀವಿ ಅಂದರೆ ಅಸಿಡಿಕ್ ಸೊಲ್ಯೂಷನ್ ಆಫ್ ಜಿಂಕ್ ಈಸ್ ಡಿಸಾಲ್ವ್ಡ್ ಇನ್ ಮರ್ಕ್ಯುರಿ ಈಸ್ ಯೂಸ್ಡ್ ಆಸ್ ಎ ರೆಡ್ಯೂಸಿಂಗ್ ಏಜೆಂಟ್. ಸೊ ಅಸಿಡಿಕ್ ಸೊಲ್ಯೂಷನ್ ಆಫ್ ಜಿಂಕ್ನ ಮರ್ಕ್ಯುರಿಯಲ್ಲಿ ಡಿಸಾಲ್ವ್ ಮಾಡಿ ಅದನ್ನು ರೆಡ್ಯೂಸಿಂಗ್ ಏಜೆಂಟ್ ಆಗಿ ಯೂಸ್ ಮಾಡ್ತಾ ಇದ್ದೀವಿ. ಸೊ ಇಫ್ ಯು ಟೇಕ್ ಅಸಿಟೋನ್ ಇಟ್ ಈಸ್ ರೆಡ್ಯೂಸ್ಡ್ ಟು propane. If you take acetophenone and you reduce by Clemmensen reduction, we reduce this acetophenone to ethyl benzene. So this is the Clemmensen reduction. So and here in this Clemmensen reduction, the reaction or the reduction takes place at the surface of the zinc metal acts as a catalyst over here. So coming to the mechanism involves reduction under acidic condition. So the reaction condition ನೋಡೋದಾದರೆ ನಾವು ಏನು ಮಾಡ್ತೀವಿ, ರಿಯಾಕ್ಷನ್ ಅಸಿಡಿಕ್ ಕಂಡೀಷನಲ್ಲಿ ಕ್ಯಾರಿ ಔಟ್ ಮಾಡ್ತೀವಿ. ಸೊ ಜಿಂಕ್ ಮೆಟಲ್ನ ಮರ್ಕ್ಯೂರಿಯಲ್ಲಿ ಡಿಸಾಲ್ವ್ ಮಾಡಿಕೊಂಡು ಈ ರಿಯಾಕ್ಷನ್ನ ಅಸಿಡಿಕ್ ಕಂಡೀಷನಲ್ಲಿ ಕ್ಯಾರಿ ಔಟ್ ಮಾಡ್ತೀವಿ. So you can see here, first in the first step the carbonyl group is protonated. So you get a protonated carbonyl group. So this protonated carbonyl takes up the electrons from the metal atom. So the metal which is employed over here is a zinc metal. We all know that metals are electropositive in nature. They are easily donate electrons. So you can see here the carbonyl oxygen is getting protonated, and you get a protonated carbonyl. So this gets isomerized. The pi bond of CO gets shifted on the oxygen. As a result, you get positive charge on the carbon. This is the positive charge on the carbon. Now this positive charge on the carbon, we have got the positive charge on the carbon. Since the metal is electropositive in nature, it donates 2 electrons. So 2 electrons are donated by the metal. 1 electron is donated to this carbon bearing the positive charge, and this positive charge is neutralized. 1 more electron is donated so that the carbon gets negative charge, get 1 more electron, and it bears negative charge. Now this carbon, this intermediate where in which the carbon having negative charge under the acidic condition abstracts the proton, and it forms CH or CH. Similarly, the lone pair of electrons present on the OH on the oxygen will abstracts the proton in the medium, that is from the acidic medium. As a result, you get an oxonium ion. This oxonium ion is removed as water molecule. Again you get a positive charge on carbon. So to neutralize this positive charge, the 2 electrons are donated from the zinc metal. Zinc metal donates electron, and it is converted into Zn2 plus. 1 electron is donated to the carbon to get neutralized, and 1 more electron is donated to, as a result, the carbon gets negative charge. This negative charged carbon will abstract the proton from the medium. As a result, you get an hydrocarbon. So this is the mechanism of Clemmensen reduction. Coming to the Wolff-Kishner reduction. So here the Wolff-Kishner reduction is also a good reduction process for reducing aldehydes or ketones into hydrocarbons. So illu ನಾವು ಏನು ಮಾಡ್ತೀವಿ, aldehydes ಮತ್ತು ketonesನ hydrocarbons ಆಗಿ reduce ಮಾಡ್ತೀವಿ. But the reducing agent what we employ over here is we use a basic solution of hydrazine under the basic conditions. So we use the basic solution of hydrazine to reduce the carbonyl group to a methylene group. So Clemmensen reduction is good for the reduction of ketones, but compared to the aldehydes. So both aldehydes and ketones on treatment with hydrazine followed by heating with KOH, that is alkaline base, basic condition, basic hydrazine, in the presence of ethylene glycol, this carbonyl group is converted into methylene group, and the aldehydes or ketones is converted into hydrocarbons. So this reaction is Wolff-Kishner reaction. You can see this here in the reaction. The acetaldehyde, when it is heated, so this, when it is heated in the basic solution of hydrazine, the carbonyl group of acetaldehyde is converted into methylene group, that is acetaldehyde is converted into ethane. So here is the mechanism for the formation of hydrocarbon for the reduction of hydrocarbon. Since we know this reaction is carried out in the basic solution, basic medium, so we all know that when aldehyde or ketone is reacted with hydrazine, hydrazone is formed. So this is hydrazone, this is hydrazone. Hydrazone is formed with the elimination of water molecule. This hydrazone, under the basic conditions, the hydrogen atom of NH2, one of the hydrogen atom of the NH2 is released. So since this hydrogen atom of NH2 is very difficult to remove, we use heating. We increase the temperature. So as a result, we get NH minus. The negative charge on the nitrogen is delocalized. As a result, we get a negative charge on the carbon. So thus negative charge on the carbon abstracts the proton, or abstracts one proton from the water molecule. As a result, you can see this intermediate having N double bond N. So similarly, the base will abstract this proton, so this hydrogen attached to the nitrogen. As a result, again you get this negative charge. The negative charge is delocalized and you get negative charge on the carbon. So these steps are repeated, and finally you get an hydrocarbon. So this is how the mechanism takes place. So first aldehyde ಅಥವಾ ಕೀಟೋನು ಹೈಡ್ರೋಜಿನ್ ಜೊತೆ ರಿಯಾಕ್ಟ್ ಆದಾಗ ಹೈಡ್ರೋಜೋನ್ ಬರುತ್ತೆ. ಹೈಡ್ರೋಜೋನ್ ಇಲ್ಲಿ ಕಾಣಿಸ್ತಾ ಇದೆ, ಸಿ ಡಬಲ್ ಬಾಂಡ್ NH2. ಈ NH2 ನಲ್ಲಿರ್ತಕ್ಕಂಥ ಒಂದು ಹೈಡ್ರೋಜನ್ ಆಟಮ್ ಈಸ್ ರಿಮೂವ್ಡ್ ಬೈ ದ ಬೇಸ್ OH ಮೈನಸ್. ಅದರಿಂದ ನೈಟ್ರೋಜನ್ ಮೇಲೆ ನೆಗೆಟಿವ್ ಚಾರ್ಜ್ ಬರುತ್ತೆ. ಈ ನೆಗೆಟಿವ್ ಚಾರ್ಜು ಡಿಲೋಕಲೈಸ್ ಆಗುತ್ತೆ. ಡಿಲೋಕಲೈಸ್ ಆದಾಗ ಕಾರ್ಬನ್ ಮೇಲೆ ನೆಗೆಟಿವ್ ಚಾರ್ಜ್ ಬರುತ್ತೆ. ಈ ಕಾರ್ಬನ್ ಮೇಲೆ ಇರ್ತಕ್ಕಂಥ ನೆಗೆಟಿವ್ ಚಾರ್ಜು ವಿಲ್ ಅಬ್ಸ್ಟ್ರಾಕ್ಟ್ ಒಂದು ವಾಟರ್ ಮಾಲಿಕ್ಯೂಲಿಂದ ಒಂದು ಹೈಡ್ರೋಜನ್ನ ಅಬ್ಸ್ಟ್ರಾಕ್ಟ್ ಮಾಡಿಕೊಳ್ಳುತ್ತೆ. ಆ್ಯಸ್ ಎ ರಿಸಲ್ಟ್ ಯು ಗೆಟ್ ದಿಸ್ ಇಂಟರ್ಮೀಡಿಯೇಟ್, ಸೊ ವಿಚ್ ಇಸ್ ಹ್ಯಾವಿಂಗ್ N double bond NH. ಸೊ ಅಗೇನ್ the hydrogen atom attached to the nitrogen is removed by the base. ರಿಮೂವ್ ಮಾಡಿದಾಗ ನೆಗೆಟಿವ್ ಚಾರ್ಜ್ ಮತ್ತೆ ಬರುತ್ತೆ ನೈಟ್ರೋಜನ್ ಮೇಲೆ. ಆ ನೈಟ್ರೋಜನ್ನ ನೆಗೆಟಿವ್ ಚಾರ್ಜ್ ಡಿಲೋಕಲೈಸ್ ಆದಾಗ ಕಾರ್ಬನ್ ಮೇಲೆ ನೆಗೆಟಿವ್ ಚಾರ್ಜ್ ಬರುತ್ತೆ. ಆ ಕಾರ್ಬನ್ ಮೇಲೆ ಬಂದಿರತಕ್ಕಂಥ ನೆಗೆಟಿವ್ ಚಾರ್ಜ್ ಹೇಗೆ ನಲಿಫೈ ಆಗುತ್ತೆ ಅಂದರೆ, ವಾಟರ್ ಮಾಲಿಕ್ಯೂಲಿಂದ ಮತ್ತೊಂದು ಪ್ರೋಟಾನ್ನ ತಗೊಂಡು ಇಟ್ ಗೆಟ್ಸ್ ನಲಿಫೈಡ್. ಸೊ ಆ್ಯಸ್ ಎ ರಿಸಲ್ಟ್ at the end of the reaction we get hydrocarbon. So next, coming to the reduction of aldehydes and ketones with lithium aluminum hydride or sodium borohydride. So lithium borohydride ಮತ್ತು aluminum borohydride ಇವೆರಡು ಒಳ್ಳೆ reducing agents. They are good reducing agents. They reduce aldehydes and ketones to alcohols. So if we employ this LAH and NABH4, so you can reduce this aldehydes and ketones to alcohols. So aldehydes na tagondu reduce madidre we usually get primary alcohols. Ketones na reduce madidre we get secondary alcohols. So these two metal hydrides are quite different in their reactivity. Eradu reactivity differences ಇದೆ ಈ ಎರಡು metal hydrides. So lithium aluminum hydride is a powerful reducing agent. It not only reduces the aldehydes and ketones but also carboxylic acid, esters, amides and nitrates. So sodium borohydride, lithium aluminum hydride ಎರಡನ್ನೂ ಕಂಪೇರ್ ಮಾಡಿಕೊಂಡಾಗ, ಸೊ lithium aluminum hydride is a strong reducing agent. ಇದು ಬರೀ ಆಲ್ಡಿಹೈಡ್ ಮತ್ತು ಕೀಟೋನ್ ರೆಡ್ಯೂಸ್ ಮಾಡೋದು ಅಲ್ಲದೆ ಕಾರ್ಬಾಕ್ಸಿಲಿಕ್ ಆ್ಯಸಿಡ್ಸು, ಎಸ್ಟರ್ಸು, ಅಮೈಡ್ಸ್, ನೈಟ್ರೈಲ್ಸ್ ಇವನ್ನೂ ರೆಡ್ಯೂಸ್ ಮಾಡುತ್ತೆ. ವೆರಾಸ್ sodium borohydride will reduce only aldehydes and ketones. So therefore to reduce a aldehyde or a ketone carbonyl group, so without affecting an ester group or carboxylic acid or an amide or a nitrile group which is present in the same molecule. So you can go for sodium borohydride instead of using lithium aluminum hydride, which reduces lithium aluminum hydride, which might reduce aldehyde as well as your ester or amide or nitrile or carboxylic acid which is present in the molecule, which is present in the same molecule. So reduction of carbonyl compounds with lithium aluminum hydride. So hydride ion ಈಗ ಆಲ್ಡಿಹೈಡ್ ಅಥವಾ ಕೀಟೋನ್, this aldehyde and ketone, when this aldehyde and ketone to this aldehyde and ketone, when you react with, when you add a hydride ion, that is H minus ion, you get alkoxide ion. This alkoxide ion can be protonated by a weak acid or a base to give alcohols. So lithium aluminum hydride and sodium borohydride act as a good reducing agents, good hydride source of hydride agents, good source of hydride ions. They act as a good source of hydride ions. So lithium aluminum hydride, as I said earlier, it is a good reducing agent, powerful reducing agent. Apart from reducing the aldehyde or ketonic group, it also reduces esters, acids, amides and nitriles. So you can see here the benzaldehyde, if it is reduced with lithium aluminum hydride, it is converted into benzyl alcohol. Sodium borohydride. So sodium borohydride is also a good reducing agent, but it is very mild compared to lithium aluminum hydride, and it only reduces the aldehydes into primary alcohols. The same reaction can be carried out by using sodium borohydride. So as I said, this is the difference between the lithium aluminum hydride and sodium borohydride. So lithium aluminum hydride, you can see here, is a ester. This molecule is having a ester group along with an aldehyde group. So here, when you reduce this molecule with lithium aluminum hydride, this ester group is reduced as well as the aldehyde group is also reduced. The same molecule, when you reduce with the sodium borohydride, it selectively reduces only the aldehyde group. You can see here. So sodium borohydride is selectively reducing the aldehyde group, whereas lithium aluminum hydride is reducing both the ester group as well as the aldehyde group. So this is the difference between the sodium borohydride and lithium aluminum hydride. So coming to the managed reaction. So managed reaction ಅಂದರೆ ಏನು ಅಂತ ನೋಡೋದಾದರೆ, aldehydes and ketones containing alpha hydrogen atom undergo condensation with formaldehyde and a secondary amine to produce beta amino carbonyl compound, which is known as managed base, and this reaction is called managed reaction. You can see here. So aldehydes ಅಥವಾ ketones, ಯಾವ aldehydes ಮತ್ತು ketones ಅಲ್ಲಿ ಆಲ್ಫಾ ಹೈಡ್ರೋಜನ್ ಇದೆಯೋ ಅವು ಫಾರ್ಮಾಲ್ಡಿಹೈಡ್ ಮತ್ತು ಸೆಕೆಂಡರಿ ಅಮೈನ್ ಜೊತೆ ಕಂಡೆನ್ಸ್ ಆಗಿ ಒಂದು ಅಮೈನೋ ಕೀಟೋನ್, ಬೀಟಾ ಅಮೈನೋ ಕೀಟೋನ್ ಅಥವಾ ಬೀಟಾ ಅಮೈನೋ ಕಾರ್ಬೊನಿಲ್ ಕಾಂಪೌಂಡ್ಸ್ is obtained as a product, which this reaction is called managed reaction. So I hope you have understood. And coming to the summary, so in this session we have discussed different reduction reactions of aldehydes and ketones, how Clemmensen reduction and Wolff-Kishner reduction can be used to reduce aldehydes and ketones into hydrocarbons, and how lithium aluminum hydride and sodium borohydride can be used to reduce aldehydes and ketones into alcohols. So as I said earlier, if you use aldehydes you get primary alcohols, if you use ketones you get secondary alcohols. So and I also stressed that lithium aluminum hydride is a strong reducing agent. It reduces aldehyde group as well as ester, carboxylic acid group, amides and other uh, derivative groups. Whereas sodium borohydride selectively reduces only aldehydic or ketonic group. And we all at last we saw managed reaction. So have a nice day. Thank you.